I feel like you've grown up so much because now we're going to start proving using PMI. And here's your very first example. But before I get started with the very first example, I want to give you some hints, some mathematical properties that you may need to use a lot, okay? So consider something like this, 4n k plus 1, okay? I just want you to know you can write this two different ways. You can write it this way, but isn't it also just 4n to the k times 4n to the 1 power? Or you don't have to write the 1 either, okay? So if you can separate these and recognize these kind of little things, I think it might be easier for you to recognize things that you can do. So for example, k plus 2 is going to be what? A b to the k times ab to the second power. Because remember, when you have the same base, you can add the exponents, okay? All right, so that's a hinty. You'll see why we need that, okay? Let's go here. So right here, I have 1 plus 5 plus 9 plus 13 plus 4 and minus 3. Now, again, this is number 8 from your textbook. I'm just showing you an example here. This is a series. What kind of series is it? Oh, it's an arithmetic sequence. Therefore, it's an arithmetic sequence. And we're looking for the arithmetic series. We're looking for the magical formula that's going to add these up for us for this specific arithmetic sequence. And you're right, it is here. But you need to prove that this actually is this. When you add 1, 5, 9, 13 all the way to infinity, this arithmetic series, it's going to add up to this right here. And let's see how we get that, okay? So there's a couple of things. There's 3 steps always, okay, when you're proving by induction. So first step is the easy part. So if you're taking a test, you should at least get the first step and the second step, okay? Maybe you can't finish the proof, but you should at least get the first step. The first step is to verify, okay, verify that n equals 1, n equals 2, at least 2 things. So here's what I mean by that. Verify this formula actually works. So let's let n equal 1. What does that mean? It means we're going to use this formula here. 1, 2 times 1 minus 1. Does that equal, well, what does that mean? It means this. It means if I have the first value, it should be the first value. So it's 1 times 2 minus 1, which is 1. Does that equal a sub 1? This is a sub 1, right? Right? So that's 1, that they equal. If you're confused, we'll get the second one. N equals 2. It means 2 times 2 times 2 minus 1. That equals 2 times 4 minus 1. That equals 3 times 2, which is 6, right? This means A1 plus A2 because it's 2. It means, does that equal 1 plus 5, which is A sub 1 and A sub 2? 6 equals 6, therefore it's good. That means this formula is valid. And you're right, we've only shown it twice, but if you want, you can show 1, 2, 3 if you'd like. And it does work for 3. You want to try it? Let's try it. Okay, 9. I mean, it's 1 plus 5 plus 9, which should be 15. Let's see. If I plug in a 3 here, it's 3. 6 minus 1 is 5. 15. 15, right? So we said here 15. See, this formula works. Now, the book actually only requires that you do it for 1, but we'd like to ask you to do n equals 2 and n equals 2. First step, always verify the first 2. It works, okay? Remember, this is the actual formula that we have to prove using the left-hand side, okay? Let's go to the second step. Again, these steps are necessary. You must, it's mandatory that you show this. So first step, verify for n equals 1 and n equals 2 that this formula is true. Second step is this. Assume that k is some integer value, a positive integer. So I'm going to write this as positive integer. The k is some positive integer. Now, we're saying that the first one works and the second one works, right? K is anybody in any position along this sequence. That's what k is. So it's some k. And we're going to let n equal k. Okay. All this will make sense, but you have to declare all this. This is a mandatory step. So we're going to say s sub k is equal to 1 plus series, right? This is a series, plus 5 plus 9 plus 13 plus ... plus, remember, n equals k, so we're going to replace this n with k minus 3. We're going to show that it equals k 2k minus 1. We replace all the n's with k's basically because we're letting n equal k. Okay? Then if n equals k plus 1, because we're trying to show the next one is also valid. We're saying that if we put any k, this is true. That means if n is k plus 1, the next one in this series, then it's also true. So sk plus 1 is equal to 1 plus 5 plus 9 plus ... plus, right? But here we're going to go 4k minus 3 plus 4k plus 1 minus 3. But watch here, stop here. We're trying to show that this here, we're trying to show that this is going to equal this when n equals k plus 1. So we have to stop here because we know that this is true because we proved it here. But we don't know that this, when we add another term, that it's going to equal our goal. So we have to stop here and write our goal. I'm going to write our goal like here. I'm going to write our goal. I wish I had another, actually I'm going to write it here. Let's actually write it here. So I always write a goal for myself. This is what I need to reach. My goal is this. My goal is k plus 1 has to equal this guy, k plus 1. So it's going to be k plus 1 to k plus 1 minus 1. You guys see that? That's my goal. But when I simplify this, I should get this. K plus 1, 2k, 2 minus 1. So it's going to be 2k plus 1. This is my goal. That means I'm going to take this left-hand side here, and naturally and organically, it's going to turn out this. It's pretty magical. I forgot a 1 here, huh? Sorry. It's magical. This left-hand side will eventually reach your goal. Okay? But you can't set these equal to each other yet because you have to verify that it's true. You have to prove to me that it's true. So let's work with the left-hand side here. Now, tell me, we have this set up, but you know this part here? Where have you seen this part? Where have you seen it? You're right. This part is actually just from this, which we proved that it's true, and we've assumed that, right? So this guy is just s sub k. I'm going to simplify all this as just s sub k, okay? Plus, and we have this part here. So I'm going to rewrite that 4k plus 1 minus 3. So this whole part is just s sub k, and we're going to add one more, okay? Now, we have s sub k plus, when I simplify all this, I get 4k, because 4k plus 1 is 4k times 4 minus 1, so it's going to be plus 1, okay? So I have that. But wait a minute, so I just simplify that, and I know that this whole thing is s sub k. But wait, don't you know something about sk? Don't you know that sk is actually equal to this? Isn't sk actually this sum here? So what are you going to do? You're going to replace that. Replace it with what you know, substitute. 2k minus 1 plus this part here comes down. Okay? So let's simplify all this. And remember, keep your eye on the goal. Is this going to turn out like this? Because right now, it doesn't look anything like it. So what we're going to do is we're going to multiply that. 2k squared minus k plus 4k plus 1. A little bit of algebra, 2k squared. Haya plus 3k plus 1. It's a quadratic, I see. So if I factor it, oh my gosh, this is where the magic happens. You're like, wait. This looks like something. Oh, it looks just like my goal. Whoa! Remember, your goal is easy to set. You simply take this guy here and substitute it for k plus 1. And you're like, wait, so this is equal to this. Okay? So you should be really excited, but you have to do a third step. Your third step is this. You see how organically it happened? You had your goal, but you've reached it organically. That's what you're trying to do. Now, third step is to say this. Therefore, this 3 dots means therefore. Therefore, we conclude that the formula is valid for all positive integers n. But you know this for all positive integers? You're going to see a lot of times I'm going to just write like this. It's valid for all. For all is mathematical symbol is this. For all positive integers n. So this whole statement here can be written like this. For all positive integers n. So again, First step is to verify for n equals 1 and n equals 2 and just plug it into the formula to make sure that it's true. Okay? Step 2 is simply assuming that k is any positive integer and letting n equal k, substituting it, and then you have to show for n equals k plus 1. Set your goal, that's step like 2.5, right? Setting your goal and then organically reaching the goal and then making that conclusion. Okay, so that was the first example. I'm gonna show you a few more examples in the next videos. Okay, hope you're enjoying this weird proof. Bye.